Welcome back, Algebros. It's time for the granddaddy of all algebra units. And to that I ask you, what the heck is a quadratics? Well, in one of our past units, we've seen functions and the different kinds of ones that we might see out there in the wild forest of algebra. Some might look like straight lines, some might look like zigzags, some are a little bit of waves, some start in one place, some have invisible lines that they never cross. But one of them that we saw the most frequently was actually the quadratic, and that was for good reason. It's the one we're going to focus on the most. It's those U-shaped ones that you saw before. But that's what it looks like on a graph. How about the equations themselves? Well, you might remember the very most basic one, which we saw to be f of x equals x squared. We called this the base, or the Dotson equivalent back then. But now let's formally define it. Quadratic means that the highest x exponent is 2, which you can see here with the fact that we call it x squared. A couple examples of some quadratic expressions. Obviously, the most basic of x squared is a thing. But if we think about some of our transformations, something as easy as x squared plus 1 is still quadratic. Bonus points if you remember what that plus 1 does. How about something, say, like x minus 5 on the inside with a square up here? That could also be quadratic. Or how about something like negative 4x squared? All of these are some of the most basic ways that we can see transformations of a quadratic. And again, we've seen exactly what each one of these transformations does. And I'll be asking you about that in class. However, we can get a little bit more wild. I can have something like x squared plus 5x plus 6. And yes, indeed, that is also quadratic. If we hop into GeoGebra, we're going to be able to see that each one of these takes on that U shape. How about something like x minus 2 into x plus 2? Something like this with two different chunks as such. This is probably a new form for you guys, and I wouldn't blame you if it were. It's basically two small little expressions multiplied together. The entirety of x minus 2 multiplied by x plus 2. We'll see a little bit more about that in the future, but this is an example of a binomial times a binomial. Don't worry, we'll learn about that later. The important thing I want you to take away from this is that sometimes the x squared that we're looking for to make it quadratic isn't immediately visible. In other cases, like the ones you've seen before, you can kind of get a gist of where the x squared is. Not in this one. At least not immediately. But you'll see. The graphs look like what we call in math as the fancy word, a parabola. What is a parabola? It's basically the U shape that you've seen before. So, the most basic form of the quadratic would look something like this. Starting over here in the origin, and then we can transform it as we see fit. U shapes here, here, and everywhere. Some are thin, some are wide. You get the picture. We'll do a quick GeoGebra adventure in order to see this a little bit more in depth. But I did want you guys to get a feel for what the expressions look like and what the graphs look like. Stay tuned for the GeoGebra adventure in just a moment.